Linear Algebra Lesson 3, Vector Operations. Hello everyone, and welcome back to the hidden world of numbers. In the previous lesson, we learned about scalars and vectors. We discovered that a scalar has only magnitude, while a vector has both magnitude and direction. Today, we'll study one of the most important topics in linear algebra, vector operations. Vectors are not only used to describe quantities, they can also be manipulated mathematically. We can add vectors, subtract them, multiply them by scalars, calculate their magnitude, determine unit vectors, and compute the dot product. These operations form the foundation of linear algebra and are widely used in engineering, physics, robotics, computer graphics, data science, and artificial intelligence. Let's begin with the first operation, vector addition. What is vector addition? Vector addition is the process of combining two or more vectors to produce a new vector called the resultant vector. In mathematics, vectors are usually represented by bold letters, such as and, or by placing an arrow above the symbol, such as or. A two-dimensional vector can be written as or simply as. Both notations represent the same vector. The first component represents movement along the x-axis, while the second component represents movement along the y-axis. To add two vectors, we simply add their corresponding components. Practical example. Imagine you walk 5 meters east. Then you walk 3 meters east. Instead of describing these movements separately, we combine them. The resultant vector is 8 meters east. This is one of the simplest examples of vector addition in everyday life. Another example is GPS navigation. When your phone calculates your movement after several small steps, it combines those movements using vector addition. Head-to-tail rule. Besides adding vectors numerically, we can also add them graphically. Draw the first vector. Then place the tail of the second vector at the head of the first vector. Finally, draw a new vector from the starting point of the first vector to the ending point of the second vector. This new vector is called the resultant vector. This graphical method is known as the head-to-tail rule and is widely used in physics and engineering. Now let's move to our second vector operation, vector subtraction. What is vector subtraction? Vector subtraction is the process of finding the difference between two vectors. Instead of combining vectors, we determine how one vector differs from another. Example. Imagine you walk 10 meters east. Later, you walk 4 meters west. Your final displacement is 6 meters east. This is a simple real-life example of vector subtraction. Another example is an airplane. Suppose an airplane flies north, while a strong wind pushes it south. The airplane's actual movement is determined by subtracting the wind vector from the airplane's velocity vector. This calculation is used in aviation every day. Scalar multiplication. Let's move to our third vector operation. Scalar multiplication means multiplying every component of a vector by the same scalar. A scalar is simply a real number. Practical example. Suppose a car travels 20 kilometers east. If the driver doubles the journey while keeping the same direction, the displacement becomes 40 kilometers east. Here, the scalar is 2. Similarly, if the car returns along the same road, we multiply the vector by -1, changing only its direction. This is why scalar multiplication is useful in physics, engineering, and computer graphics. Magnitude of a vector. Now, let's study another important concept, the magnitude of a vector. The magnitude of a vector is its length or size. It tells us how long the vector is, regardless of its direction. The magnitude of a vector v is denoted by absolute of v. Practical example. Imagine you're flying a drone. The drone moves 3 meters east and 4 meters north. What is the shortest distance from the starting point to the final position? Using the magnitude formula, we find that the distance is 5 meters. This is why magnitude is useful in navigation, robotics, and engineering. Unit vector. Now let's discuss the unit vector. A unit vector is a vector whose magnitude is exactly 1. It is used to represent direction only, without changing the original direction of the vector. Dot product or scalar product. Our final vector operation for today's lesson is the dot product. The dot product combines two vectors and produces a scalar, not another vector. Summary. Let's quickly review what we've learned today. We studied the most important vector operations in linear algebra. We learned that vector addition combines two vectors by adding their corresponding components. Vector subtraction finds the difference between two vectors by subtracting corresponding components. Scalar multiplication multiplies every component of a vector by the same scalar. Magnitude tells us the length of a vector. A unit vector has a magnitude of 1 and represents direction only. The dot product combines two vectors to produce a scalar value and is widely used in artificial intelligence, machine learning, physics, and computer graphics. These operations are the building blocks of many advanced topics in linear algebra. Mastering them will make it much easier to understand matrices, vector spaces, linear transformations, eigenvalues, and many real-world applications. Thank you for watching Lesson 3 of our Linear Algebra course. If you found this lesson helpful, like the video, subscribe to the Hidden World of Numbers, and share it with your friends who are learning mathematics. In our next lesson, we'll begin exploring matrices, what they are, how they are represented, and why they are one of the most powerful tools in linear algebra. Until then, keep learning, keep practicing, and remember, every great mathematical idea begins with understanding the basics. I'll see you in the next lesson.